Lesson 1.7 is on integer exponents and some properties of them, some properties in addition to the properties that we talked about in lesson 1.6. So starting with example 1, we're going to talk about the zero exponent property. So here we're playing a card matching game with some classmates. 4 matches have been made. It's Marcella's turn and she chooses 3 to the 0. What card would complete her match? Okay, so we're going to look at a pattern here. Okay, we have 3 to the 4th power. That's what we're going to start with. 3 to the 4th power means 3 times 3 times 3 times 3. Okay, and that's going to give us 81. Okay, now we're going to look at 3 to the 3rd power. 3 to the 3rd power is 3 times 3 times 3, and that gives us 27. So the match for 3 to the 3rd would be 27. 3 squared is 3 times 3, which is just 3. Not 3, sorry, that should be 9. 3 times 3 is 9, so let me go ahead and fix that. 3 to the first power is just 3. So that leaves us with 3 to the 0 power, because we're decreasing by power. 4, 3, 2, 1, 0. So what's happening here is each time we're dividing by 3. 81 divided by 3 gives us 27. So 81 divided by 3 gives us 27. Okay, then 27 divided by 3 gives us 9. 9 divided by 3 gives us 3. And following that pattern, to get our last box, 3 divided by 3 would give us 1. So what happens here is whenever we raise something to the 0 power, we are going to get 1. Okay? So here the zero exponent property states that a to the 0 equals 1, assuming that a does not equal 0. So any number that we put in for a and we raise it to the first or 0 power will always get 1. So Marcella needs to find the 1 card in order to complete her match here. Okay? So here, again, 3 to the 0 equals 1. So there's some other cases that we could have, like if we have 3 to the 3rd power divided by 3 to the 3rd power, our quotient property tells us when we divide and we have the same base, we subtract our exponent. So 3 minus 3 gives us 0, so 3 to the 0 power. Same thing here. Everything simplifies to 1. So 3 to the 0 equals 1. There are 4 try-it problems for you to try. So go ahead, pause the video, try these on your own, and then resume the video when you're ready to check your answer. So negative 7 to the 0 power equals 1. 43 to the 0 power equals 1. 1 to the 0 power equals 1. 0.5 to the 0 power equals 1. Okay? The 0 exponent property states that any number raised to the 0 power will always equal 1. So it doesn't matter what the base is. If the exponent is 0, it'll equal 1. Example 2, we're going to look at the negative exponent property. Okay? We have the expression 4 to the 3rd divided by 4 to the 5th. And we're going to simplify it. So 4 to the 3rd divided by 4 to the 5th can be rewritten as a fraction. Okay? 4 to the 3rd over 4 to the 5th. Now, we can rewrite 4 to the 3rd as 4 times 4 times 4. Okay? It's 4 multiplied 3 times. And in the bottom, we have 4 times 4 times 4 times 4 times 4. Okay, it's multiplied 1, 2, 3, 4, 5 times because our exponent is 5. Now here, we can simplify. Okay, top and bottom has some common factors. 4. Okay, 4 divided by 4 gives us 1, so those can simplify. 4 divided by 4 gives us 1, so that simplifies. 4 divided by 4 gives us 1, so that simplifies. And then I'm left with 2 4s in the bottom. Nothing's left in the top. So what this means is I have 1 over 4 times 4, or I can rewrite that as 1 over 4 squared. Now, I can rewrite this using a negative exponent. Whenever you have something in the bottom, you can move it to the top by flipping the sign. So this would become 4 to the negative second power. Okay. Another way to look at this is thinking about your subtraction property when you have the quotient of powers. You would subtract your exponents. You have the same base, so you take 3 minus 5, and 3 minus 5 gives us negative 2. So that's another way to get your negative exponent. So 4 to the negative second power. So here, our negative exponent property states that when you have a base raised to a negative exponent, you could rewrite it as 1 over a to the n, where your exponent is now positive. So here, if we had 4 to the negative second power, we could rewrite that as 1 over 4 to the second power. There are 3 try-it problems for you to do. You are going to write each expression using a positive exponent. So go ahead, pause the video, and try these 3 on your own. So for the first one, we would have 1 over 8 to the second power. 2 to the negative fourth power becomes 1 over 2 to the fourth power. And then 3 to the negative fifth would become 1 over 3 to the fifth. So when you have a negative exponent, you just bring it to the bottom and make it positive. Example 3, it says write the expression 1 over 7 to the negative third power with a positive exponent. So if we have a negative exponent in the denominator, we can just move it to the top and make it positive. So 1 over 7 to the negative third power will become positive 3 up top. So 7 to the third power would be the equivalent for this example. So when you have a negative exponent in the bottom, okay, you can just move it to the top and make the exponent positive. There are 2 try-it problems for you to do. So go ahead, pause the video, try these 2 on your own, and then resume when you're ready. So 1 over 5 to the negative third power will become 5 to the third power. 1 over 2 to the negative sixth power will become 2 to the sixth power. Okay? In this lesson, the key concept, we talked about the zero exponent property. Whenever you raise something to the 0 power, you get 1. The negative exponent property, if you have a to the negative n, so your power is negative, you can bring it to the bottom and make it positive. We also talked about if you had 1 over a to the negative n, you can rewrite that as a to the positive n. Okay? So those were the key concepts. There are 3 do you know how problems for you to do, 4, 5, and 6. 5 has parts A and B. So go ahead and answer those 3 problems, and then resume the video when you're ready to check your answer. The first one, we have the 0 power. Whenever you have something raised to the 0 power, it always equals 1. 7 to the negative sixth power using a positive exponent, so we would write 1 over 7 to the sixth power. 1 over 10 to the negative third power, writing that as a positive exponent, we would just move it to the top, so 10 to the third power. And then for number 6, it says evaluate x to the 0, y to the negative second for x equals 4, y equals 3. So before we solve this one, I would rewrite y to the negative second in the bottom. So we have 27 x to the 0 over y to the second. Now substitute in 4 for x and 3 for y. So we have 27, 4 is x, so 4 to the 0 power, over y squared, so 3 squared. By order of operations, I have to do my exponents first. So I'm going to have 27, 4 to the 0 power is 1, so I have 1. And then in the bottom, 3 to the second power is 3 times 3, which is 9. Now I'm going to do my multiplication up top. 27 times 1 is 27. So I'm left with 27 divided by 9. And 9 goes into 27 3 times. So my final answer is 3.